Hey everyone, so what I'd like to do this afternoon is actually take you through a class I would give to year nines. It's very much based around experiments, so from that perspective, I'm going to talk through what we would actually do. And it falls within the unit reaction types, and in particular, this class will be a double lesson focused on looking at the conservation of mass, which is a particular law. Very highly regarded, and the person, Mr. Lavoisier, who actually founded this law, is considered the father of modern chemistry. And I'd like to engage the students right from the beginning of this class by doing a little bit of a demonstration. So I'd have the Bunsen burner up the front, and I would light up a piece of magnesium and hold it up in the air, and this would shine quite bright, and some smoke would give off. And I would just ask them to describe what they actually saw that took place in front of them, and you would get those sorts of answers. Okay, it was bright and there was some smoke coming off, and I'd ask them whether that was a chemical reaction that they were actually seeing take place. And through the discussion, learning that it was, and I would put the equation up on the screen and then reflect back on our previous learning from the single class. So this would be the second lesson of this unit reaction types. And in the first one, we will go through what is a chemical reaction, and we will talk about what's called reactants, which is what you start with, and then the products, which is what you finish with. And I'd write the equation up on the board of what we saw. So it would be magnesium at the beginning plus oxygen turning into magnesium oxide. And then from there, we would actually shift into talking about how could we actually test, how could we discover the law of conservation of mass. If we were Mr. Lavoisier, how would we do that with the demonstration that I just showed? And through that, start to generate a class-wide discussion of how you would define this experiment. So not me telling them directly this is what you are going to do, but sort of guiding them through a class-wide discussion as to how that would take place. Because, for example, one of the things that they would likely raise is that they had smoke escaping. So how would we minimize that occurring? And the endpoint that I'd want them to get through to would be using what's called a crucible, and you sit that on top of a Bunsen burner tripod, and it has a little lid. So what we would do is put the magnesium into the crucible, and we would burn it much the way as I did in the air, but with the aim of actually trapping that smoke. And I would ask them from that point to actually go about designing the exact experiment. So writing up the aim, their hypothesis of what they think would occur. The hypothesis being really important because it's a little bit of a trick experiment, which I'll get to in a moment. Not a trick experiment, but what they'll generally do is they'll hypothesize that it'll either stay the same, so adhering to this law of conservation of mass, that the mass of the reactants will be exactly the same as the mass of the products, or they'll predict that it will actually go down a little bit because they see that smoke escaping from the reaction in the demonstration. So I would give them sort of 10 or so minutes in groups. So after we've had that class-wide discussion, talking about and contemplating or how we're actually going to go about testing this, giving them 10 minutes to have their aim, their hypothesis, talking as a group, well, what do they think is going to occur, and then writing out the methodology. And from that point, I would then have a quick little discussion about safety, given that we're using the Bunsen burners and that sort of thing. And from that point, actually just letting them go about conducting the experiment in groups. So I would provide supervision, of course, going around the class, making sure things are happening safely, and providing points of clarification for groups that maybe aren't a little bit certain as to what's happening. And what you'll probably get is some students unsure of, has the reaction finished? Because what will occur when that magnesium burns is it turns into a powder, and it'll sit within the crucible. So the way that they'll go about actually testing this, and again through that class-wide discussion at the start, is they would look at measuring the mass of everything first, the crucible and the magnesium, and then after. And as they're going about conducting this experiment, they would write their group's results up on the board. So we get this nice big table on the board. So it's not just their results, but across the entire class. So there's a higher level of validity and reliability about the results. So if one group has a bit of an anomaly or does something wrong, we still see the overall trend. So they get a sense of what's really happening here. Once they've finished that experiment, we'll come back together as a group and we'll have a bit of a discussion. And what they'll actually find is that overall, unless something's gone wrong in their groups, but the class-wide trend will show that the mass has actually gone up. And this seems a little bit strange because the smoke's escaping, or if they did it perfectly, shouldn't the mass have stayed the same? But the key factor here is that for the magnesium to become magnesium oxide, that sort of powder within the crucible, what actually needs to occur is oxygen is drawn in. So it's using the oxygen of the air for that as part of that chemical reaction, and the outcome of the product is magnesium oxide. So a combination of magnesium and oxygen. So I wouldn't just tell them that directly. Again, I would actually try to get them to think as a group, as a class, have a discussion. Well, guys, why is this actually happening? And that equation would still be sitting there up on the board, and I would get them to take a look at it, focus on it, and reflect on what's actually taking place. And once we come to this conclusion that, oh, okay, it's gone up because of this, I'd give them a little bit of a time to write up a brief discussion, maybe 10 minutes or 5 or 10 minutes. And then we'd move on to the second experiment. And the idea of the second experiment would be, well, okay, how do we actually control the capturing the reaction? So we don't want anything to escape. We don't want anything to draw in like the oxygen. What can we do? And I provide them with a little bit of guidance. I'd have some other product or reactants up the front. We'd have our magnesium again. We'd have some hydrochloric acid. And we'd talk about how this reaction creates hydrogen gas. And it's like, well, okay, how are we going to control this? How are we going to make sure that nothing escapes? None of that hydrogen gas escapes. And through a conversation, I'll guide it as necessary, but I do feel that the students were able to grasp this and sort of drive the creation of the experiment. We'd come to that conclusion because I'd have a nice little sort of tray of all sorts of things like beakers and conical flasks, which they can use in the experiment. Is what you would end up doing is having the hydrochloric acid in a flask, and you would use a balloon to actually capture that gas that's given off. So therefore, from this perspective, we'll actually adhere to this law of conservation of mass. And they would then have, again, time to write up the experiment, have their hypothesis. So what I feel would happen this time is most students will say, no, well, this is actually going to stay the same because we're actually stopping the gas escaping. We'll weigh the conical flask and the balloon and the hydrochloric acid, all those substances first, and then they'll go about conducting the experiment in their groups again, and you'll see them be quite surprised because as we get that nice class-wide group of results up, this time something strange is happening again. What we've actually done is we've had the mass go down. But how can the mass go down if we've controlled everything in the experiment? We've got the conical flask, we put the hydrochloric acid in, pop it on the scales, the balloon with the magnesium inside it, and we weigh that, and then we drop the magnesium in and actually have that reaction occur. You bubble, you see the balloon blow up, and we've captured that air, but it's not the same. And what we've actually will find here, again through a group discussion with an example up the front, I'm thinking, well, what's actually occurring here is that we'll realise that gravity is playing a role, and that air, that hydrogen gas within the balloon is actually suspended and not being completely weighed due to that effect of gravity and the gas rising up. So again, they're going to be thinking, well, okay, what's actually happening here? And in terms of not being able to adhere to this law, there's all these little things. And what I hope this shows them is actually how complex it was for Mr. Lavoisier many, many years ago, early in the 20th century, to actually discover this, to actually understand that this is exactly what was occurring. There was no difference between those reactants. So whatever you combine with it, it's hydrogen and oxygen turning it into water, they weigh the same. And this can sometimes be hard for people to grasp because, you can be going from those gases to the liquids or vice versa, or even to solids. And it's at this point that, again, they'd have a little bit of time to write up their discussion, but I'd want to round out the class with a bit of a reflection. And the reflection will be, okay, we've got one more single lesson left. How are we actually going to complete an experiment that actually adheres to this law? And give them some time to actually contemplate and consider this. Again, I would have all different materials up the front and prompt them as necessary to guide them as to what we could do next lesson to actually conduct an experiment that adheres or demonstrates the law of conservation as mass, because of course all the reactions, chemical reactions that are occurring are adhering to it, but we actually want to demonstrate it in an experiment. And then from there, just closing out the class with a little bit of fun where we've got these balloons full of hydrogen and we can tie them up and on a nice long stick actually light up a match and cause a little mini explosion. Nothing too big, nothing too dangerous, but not just for the fun of it. It would be very fun and I'm sure the students would appreciate and enjoy it, but what I would ask them to consider is what reaction was occurring. So what reaction type was occurring there, reflecting on the theory of the first lesson before today, and what were the reactants and the products. And coming back for that final single lesson of the week where we close things out by doing that experiment which adheres to the law and also discussing that combustion reaction which they just saw in the hydrogen mass. So I think it would be a really interesting, fun class, very engaging through both discussion and experimentation, and I'd hope that the students would enjoy it. Thank you.